Alright, so in this video, we're going to solve quadratic equations by completing the square. Okay, so there's a lot of steps here that we got to deal with. It won't take a whole lot of time once you get these steps down, but you do need to kind of memorize the process here. Okay, so first thing, you can look at example 1 as I'm going through this. So we're going to write the quadratic trinomial in standard form. Well, it's already in standard form, okay, which means everything on one side set equal to 0. Remember, in standard form, the coefficient of x squared is a, the coefficient of x is b, and c is the constant here, okay? So first thing we want to do after that's done, so we're going to move the constant to the right side, okay? So I've moved the constant over here, it becomes negative, and notice I've left space here and here, okay? Eventually I'm going to add the same value to both sides, okay? Number 3, the leading coefficient of the quadratic trinomial needs to be 1. Well, that's the case here, so I can skip this step. In a future video, we'll work some problems where the leading coefficient is not 1, all right? So let's move on to step 4. So off to the side, we want to divide b by 2, okay? Well, b divided by 2 is 6 over 2. Then we're going to square that value, okay? So it's 3 squared, which is 9, okay? Now, in step 5, we're going to add that value to both the left and right sides of the equation to maintain balance, okay? So let's add 9 to both sides. So notice that 9 goes on that, and then the 9 goes there as well, okay? So we've added 9 to both sides. Because we've added the same value to both sides, this equation is equivalent to this equation. So we've maintained balance, all right? Now, the reason we complete the square is because we want to create this perfect square trinomial on one side. It's easy to factor, okay? So we're going to factor this perfect square trinomial, and we're going to simplify the right side, okay? So the perfect square trinomial is x squared plus 6x plus 9. The factor is x plus 3 to the second power, okay? Notice this value, okay, is always going to be this b over 2 value. 6 over 2 is 3. That's going to be the value that goes here. So that makes this process quite a bit easier, okay? And then the last thing we're going to do, we've got to solve this equation using the square root method, okay? So we're going to take the square root of both sides, okay? So when we do that, on the left side, we get x plus 3. On the right side, the square root of 1, we have to take both roots into account, both positive and negative 1, okay? So first thing, we want to set x plus 3 equal to the positive square root, so positive 1. And we want to solve that resulting equation. So we're going to subtract 3 from both sides. So x equals negative 2, okay? Then we want to set x plus 3 equal to the negative root, negative 1 in this case, and solve that equation. So we're going to subtract 3 from both sides, and we get x equals negative 4, okay? All right, so pause the video and try example 2 now, okay? And then come back and check your work. Okay, already in standard form, so we want to move the constant negative 10 over to the right side. It becomes positive. I've left a blank space here because I'm going to add the same value to both sides in just a second, okay? B is negative 15, okay? So I'm going to divide that 15 by 2, so that's 7.5. I'm going to square that, or I'm going to square 15 over 2. 15 squared is 225. 2 squared is 4, okay? So I'm going to add 225 over 4 to both sides. Okay. Now remember, when we factor, it's always going to come back to this this b value, b over 2. Okay. Our middle term is negative, so when we factor, we're going to have x minus that b over 2 value, x minus 15 halves to the second power. When I combine these, I need to get a common denominator. 10 becomes 40 over 4, and 40 plus 225 is 265 over my common denominator of 4. Okay. I'm going to leave it in that form. If you make it a decimal, that's fine, but it's going to be, you'll see it's better to kind of leave it in this form. Okay, take the square root of both sides. All right. So when I take the square root of x minus 15 halves squared, I get x minus 15 halves. 265 under the radical can't be simplified. The only factors it has is 5 and 53. Okay, square root of 4 simplifies to 2. In the denominator, okay? That's great because we've got a common denominator already here, okay? So let's set x minus 15 halves equal to the positive root here, 265 over 2. I'm going to move the 15/2 over to the right side, okay? So this would be the exact answer, all right? But you can use a calculator to approximate that, and if you plug this into a calculator, you should get approximately 15.64, okay? Now let's set this x minus 15/2 equal to the negative root, so negative square root 265 over 2, okay? Add 15/2 to both sides. Again, if you want an exact answer, you can combine these into one answer or just leave it like this, but you can also use a calculator to approximate it, and we should get negative 0.64, okay? So that's how you solve quadratics using completing the square if the leading coefficient is 1.